So hi everyone, in this video we will going to learn that how to use SRVCTL and CRSCTL in RAC database. So SRVCTL is server control command which is used to modify and maintain the services, okay, and the CRSCTL which is cluster resource services, okay, so which is used to modify and maintain the cluster resources, okay. So you can see on the screen that we have enlisted the services, okay. So guys, here we will noted that what are the services and what are their functionality, okay. So we will start with the OHISD, okay. So OHISD stands for Oracle High Availability Service Demo, which helps to run all services without getting failed, right? So this is the first stack service, okay. Now the next one is CRSD, okay, which is Cluster Ready Service Demo, and this process manages resources like databases, services, listeners, and the modification and management like starting, stopping, failover operation in the Oracle cluster, okay. Next one is the OCSSD bin, right? So it is called for Oracle Cluster Based Synchronization Service Demo, okay. So this process mainly manage the node membership in the Oracle cluster, right? It is also called as CSSD monitor or CSD agent, right? Next one is OCT SSD. So it is known as Oracle Clusterware Time Synchronization Daemon. So it is manage the Oracle Clusterware timing, right? Next one is EVMD, right? So which is called as Event Management Daemon to publish the events in the Oracle Clusterware, right? The next one is GIPCD, which is Grid Inter-Process Communication Daemon. It is responsible for the nodes to communicate with each other, okay. It provides communication infrastructure for the clusterware resources. Next one is GPNPD, right? Which is called as Grid Plug and Play Daemon. So it is used to update grid plug and play profiles in the Oracle cluster. Currently it is having no functionality in the Oracle 19c, but afterward it will be start. And now we will start with the disk monitoring, okay. So you can see on the screen that we are having OSIS Mon T, okay. So it is called as Oracle System Monitoring, okay. So which is monitor the disk processes in the Oracle cluster, right? Next one is MDNSD, right? So it is called as multi-class domain. It is called as a multicast domain name service daemon, right? So it allows the DNS request in the Oracle cluster, right? The next one is Ora agent.bin. So, okay. So this is not shown in the processes, right? But it is running in the background, right? So it is called as Ora agent, right? Runs server callout scripts with fan, okay. So that is what, and also there are many like Ora root agent, okay. So which used to manage the root owned components like VIPs, virtual IPs, as well as listeners in the Oracle cluster, right? Then there are other also processes like ONS, Oracle Notification Services, which publish events on FAN in the Oracle cluster. What is FAN? So FAN is fast application notification, right? So in the Ora agent bin, it is Ora agent runs servers callout scripts, okay. When the FAN fast application notification events occurs in the Oracle cluster, so you can relate Ora agent with the ONS, okay. So these are the processes running in front of us, okay, and these are helps to sustain all the resources and their functionality in the Oracle grid infrastructure, okay. So hope guys this understands why you, right? So we will clusterware, okay. So using this d.bin command you can enlisted all the bin directories, okay. So now we will change to the bin directory, and there we will check the status of the clusterware using this CRSCTL command, okay. So this is a CRSCTL command, and using this we can check the resource status, okay. So you can see the resources are enlisted. The resources are like local resources, which are listeners, you can see they are online and stable, okay, on the both the nodes. So we have two node database, that's why. So these are all services, okay. Now the cluster resources, okay. So it is the overall collection of resources available on the entire cluster, okay. So you can see they are online on both the nodes, right? You can see data, this is a disk group, okay, ASM disk group. So archlog disk group is generally for storing the archlogs and related files, and data is for the database. So on this data disk we have stored our database and database related files like data files, redo log files, control files, sv files and p files. Okay, so these are all physical files which are stored on the database. Okay, so at the time when the cluster starts to up, okay, so at that point the CRSCD, the cluster will checks for the ASM disk group. Okay, so if find it's, so the cluster will be off, and if something is missing, so it won't up itself. Okay, also the next one is OCR what. Okay, so OCR means Oracle Cluster Registry. So it is a type of file, right? We store the configuration of the entire cluster. And next one is the vote disk, or say voting disk. So vote disk is generally a file is stored on one of the ASM disk group, and OCR also stored on the one of the ASM group. You can also do the multiplexing. Okay, you can store OCR and vote disk file on the multiple ASM disk. So in case any disk group fails, so you can take the help of the another disk groups. Okay, so voting disk generally stores the node membership in the cluster web. Next one is the ASM disk group, and this one is the network. Okay, CVU cluster verification utility. Okay, so it is running on the mother node, which is SACRE1. Now you can see that VIP virtual IPs, virtual IPs are generally used to communicate between the databases. Okay, and this is our databases. So this is a database resource. Okay, so generally the nomenclature is like aura dot the resource name and then the resource type. Okay, so you can see here it is up on both the nodes. Okay, so these are the scan virtual IPs. Okay, so scan is single client access network. So using this, the application user connect to the databases. Okay, so it is a centralized way to connect to the database. Scan. Now we will check the CRS status. You can see everything is up. Okay, so now we will switch to the Oracle user, and here we will execute the SRVCTL command. Okay, so here we will check the database status using this command, which is SRVCTL status database and then the database name. Okay, -d is for the database. You can see both the database instances are up on nodes. So SACRE1 is the node name and SACREDB1 is the instance name. Okay, so now we will stop the instance. Okay, instance means it lies on one of the node. Okay, so first of all we will stop the instance on node 2. Okay, that's why I'm mentioning SACREDB2. So using this SRVCTL stop instance -d for database, then database name is SACREDB, then -i for instance, and then instance name is SACREDB2. So now it's completed. Now we will check for the status. Okay, so you can see SACREDB2, which is on SACRE2 node, is off, right? So it is down right now. So we can start the instance using this command. Okay, SRVCTL start instance -d SACREDB, then mention the -i for instance and mention the instance name, which is SACREDB2, right? So using this command we can start the instance on the node. Okay, so it has been started. Now we will again check the database status using the SRVCTL command. So just copy it. Okay, so you can see that the instance 2 also up right now. Okay, so previously we stopped it and now it's up. Now if you want to stop the entire database, okay, so entire database includes all the instances working on all the nodes. Okay, so make sure that actually generally we don't do this. We just stop the instances on one of the nodes. Okay, and then we do our work like OS patching or any deployment on that node. Okay, so the benefit of the RAC database is like if you change something on one node, okay, so it will be populated all nodes. Okay, so it is the same DB is laying on all the servers. Okay, so now we will stop the database using SRVCTL stop database -d, then SacredDB, which is the DB name. Okay, so it will take 2 to 3 minutes. Okay, so it has been done. Now we will check the status again, that whether the entire database is off or not. So you can see DB is down on all the nodes. Okay, so now again we will go to the bin directory and check the cluster status also. So also we need to sure that it is reflecting on the cluster where status also. So you can see, yeah, you can see that both of them are shut down, right? The DB is shut down on both the nodes. So likewise we will start the database. Okay, but at a time on the production primary database we don't execute this stop database command. Okay, because if we stop the database, so users can't go to the any user don't have any connectivity to the databases. Okay, so now we started status, we start the database and status is showing up. So you can see on the cluster where also. Okay, but to make sure that never execute this command on production database. Okay, primary database you can do it on the standby. Okay, but never use it on the primary database unless if the change having the step to stop the entire database. Okay, so now we can stop the clusterware. Okay, so using the clusterware, so everything will be stopped. Okay, whether it is database, listeners or ASMDs group, everything will get stopped at this point when we execute CRSCTL stop CRS -f. -f is for forcefully. Okay, so forcefully stop each and every resources. So even if you don't mention -f, it will stop the resources. Okay, so you can see that now we will check that whether any process is running or not. Okay, so you can see nothing is running in the background. Okay, now we will log in to the second node. Okay, ps-grep daemon. You can see CRS clusterware is running on this node also. So now we will switch to the bin directory. Again we will check the status. So now you can clearly see that node 1 is stopped. Okay, clusterware on the node 1 is stopped. Now we will stop the clusterware on node 2 also. So we are executing the same command, right? So one by one it will stop. I think it's stopped. We just need to scroll down. Okay, so it has been stopped, right? Again we will check that any background process is running or not. Okay, nothing is running. So this is how we can stop the clusterware. And if we want to start the clusterware, this is the command. Okay, CRSCTL start CRS. Okay, so it will start. Okay, so clusterware is started. Just we need to so it will start. Okay, gradually it will start. It will take 15 to half an hour to entirely wake up the cluster. Okay, so you can see OHSD is running, right? So currently it will show that so just one process is remain there, CRSSD. Okay, which is the main process, right? Now after 1 hour we can check, so it should be up, right? So you can see, okay, everything is up after half an hour, right? So it will generally take 20 minutes to half an hour to entirely start the clusterware, right? So yeah, you can see local resources, right? So these are the local resources which are present on each and every group, each and every node, right? You can see database is also up, right? So this is a resource name, okay, aura dot resource name, then resource type. Okay, so using this status command we can check the resource availability, okay, whether it is online or offline. So you can see that we are unable to stop the resource using this CRSCTL command. Okay, so for that we need to use SRVCTL. Okay, so these are the resources, right? Now we will check them one by one, right? CRSCTL stop resource. So yeah, it says use the SRVCTL command instead of CRSCTL. Again we will check. Okay, so it is saying that we are unable to stop the resource using the CRSCTL command, right? Now here we will see that how to stop the database and start the database using the various options, okay, available. So you can see on the screen that using SRVCTL stop database -d and then database name, this is the default behavior by which we can stop the database. So you can stop the database normally, immediately, transactional and about. Okay, so uh, most of the time we use immediate option. Okay, most of the time SRVCTL stop database -d, then database name, then -o for the option, and then the option, okay, immediate. So most of the time immediate option is used, so you can use the immediate option instead of using the above one. So normally means it will wait until all the processes stops, okay, like the user sessions completed their executions, okay, so it will wait for that. But when you execute with the stop database along with the immediate option, it will immediately stop all the transaction user sessions and stop the database instead. And if you mention the transaction, okay, so it will stop all the incoming or outgoing connection, okay, so it won't allow any transaction on the database, okay. And we actually don't use about option, okay. In case if any zombie process is running in the background, then we can think about this. But at that time when the zombie process is running, that so we kill that oracle process instead of using this command. So you can see SRVCTL status database -d sacredb running is on the both the nodes, okay. So now we will stop the database in the normal mode, okay. You can see on the screen that we have executed with the options given, right? SRVCTL stop database -d sacredb -o normal, okay. So we will wait, it will take 2 to 3 minutes to execute the operation, and when this will be this completes, we will check again the status of the database, okay. So actually I am running this on the laptop, so it is a resource hungry clusterware, okay. So Oracle RAC is a very resource hungry software, okay, so it will take a lot of resources out of your processes, okay. So I have given only 8 GB RAM to each and every to the both the VMs, so each one having 8 GB RAM, okay. So that's why it is taking a time. So basically these are stopping and starting process, and modification processes is performed by the SDBS, okay. System DBS do this work. but the ADBs don't have access, they don't have root access. Okay, so probably these things like stopping and starting databases, okay, this can be done by the ADB also if they having access to the Oracle directories. Okay, but most of the case sysdba, the respective sysdba group will do this. Okay, so we have stopped the database in the normal mode. Now we will check for the status of the database. Okay, so again use the same command. So again it will take 2 to 3 minutes. Okay, so now we will see. Okay, so you can see that both the instances down on the nodes. Okay, now we will start the database in the open mode, right, which is the default behavior. So even if you don't mention -o open, so it will start the database in the open mode also. So by default, so we are stepping on the side and we have taken the normal shutdown as well as normal open mode to start the database. Okay, so it will again take 2 to 3 minutes. So guys, alongside we can take the status of the resources. Okay, so you can see that both the instances down, right, the database is down, right. Okay, it's starting right, starting, we are doing starting the database. Okay, so now you can see, so using this command we can take the status of the particular resources. Okay, so it is starting, right, it's showing starting on the cluster where it will take a lot of time, right. So basically the execution time of these commands are based on the resources are allocated to the cluster, right, that how much RAM consumption the database and cluster where does, how much, what type of hard disk is available there, right. So this all also the network condition. Okay, if the net is enough amount. Okay, so actually Oracle database is solely based on the memory consumption, right, so it perform all its operation on the memory structure, right. You have heard about the memory consumption of the Oracle database, right, like the HGA, system global area, PGA, programmable global area. Okay, PGA is allocated, okay, individually to each and every user who log in on the server. Okay, so if someone is having connection with the database, he has a different PGA. So you can see a SRVCTL status. So now we will check whether the database is up or not. So this okay, so this has been execution, this must have execution is performed. Now we will check on the cluster side also. So it will goes on running, right, it will goes on running. Let me see what it will give us. So once the database is up, you can log into the database after 2 to 3 minutes. Okay, so it will initiate itself. Okay, so application user can connect to the database using the scan listeners, right. Scan means single client access network. Okay, so using that, so it is lying on each and every node in the cluster where, and you can connect to any one of them, right. So the service names, there is only difference in the service name. Okay, so database having a service name like SacreDB, so the service name of each instance will be differ, like SacreDB is a database name, then SacreDB1 is the instance 1, SacreDB2 is the instance 2. So like in this way the instance is distributed, the instance name is distributed over all the nodes. Okay, so you can connect to any one of the nodes and can check the status. Okay, so for example, if OS patching is happening on the first node SacreDB1, then you can check the database status from the SacreDB2. Okay, so in this way, the availability of the database is consistent even if one of the node goes down, okay, for any service reason, right? So this is the benefit of RAC database. So it is solely on the availability purpose, right? So availability of the database for the applications are always there if you are using RAC database. But for practicing purpose, you can install max 2 node system, okay. So this is also very resource hungry, so that's why now we will stop the database in immediate option with the immediate option. So it won't wait for the transaction to happen, so it will disconnect all the users from the database immediately and stop the transaction of all the SQL queries that were triggered by those users, okay. So it won't wait, it will directly stop the database. So for that we use immediate option. So now we need to wait. So now you can see that the database immediately stopped, right? So now we will check the status. What is the status of the database, right? So you can see on the cluster from the cluster web, so CRSCTL is showing that both the databases are down, and also the SRVCTL commands output showing that DB is down on both the nodes, okay. Now you can see mount option is used for the backup and recovery operation, okay. So when the no mount option is mentioned there, okay, so that means the either your control file is missing or SP file or P file missing. For that we use no mount mode, okay. And for mount mode, it is a standard procedure to start the database in mount mode for recovery and restore and recovery operation, okay. So you should it is mandatory to open the database in mount mode when you are doing rm1 restore and recovery operation, okay. So we have started the database, now we will wait, okay. So these are all options, okay. So we generally use immediate option to stop the database, and normally we open the database in open mode, right? So SRVCTL instance also there, we have already seen in the previously that how to stop the instance, right? So generally instances are stopped, okay. We don't stop the database on the RAC database or RAC cluster, okay. That is not a good practice. So basically if you are having 4 to 5 nodes RAC database, so you can't execute the stop database, okay. So it will create an outage there, right? So instead of doing stop database, we always use stop instances. So you can see that database is up on both the servers, okay. Now we will check with the help of the SRVCTL also, okay. So cluster we are showing CRSCTL showing it is up, right? But we need to show about SRVCTL also. So you can see that this is also done. DB is up on both the database nodes. Now we can check if you want to check the listener status, okay. So you can use ps-ef grep tnsl lsr lsnr. So it will also you can see that 4 listeners are there, one is local and one for ASM and 2 for scan listeners, okay. You can see using the SRVCTL also that this local listeners are running on that both of the nodes, okay. So now we will finally take the CRSCTL status. So it is taking time because the on host we are having Windows 11, so that's why Windows 11 will consume 5 to 6 GB of RAM, okay. And we are giving 88 GB to each of the node, okay. So let's see. So you can see that CRSCTL command showing everything is up and online, right? Local resources and also the cluster resources, okay. Both the nodes SACRI1 SACRI2 and these are the cluster resources, right? So cluster resources having a naming convention like aura dot resource name then resource type, right? So we can check the resource individual also using the CRSCTL status resource, then mention the entire resource name. Okay, so one by one we will check that. Okay, so here we can see. Okay, so this ASM net listener also upright. Also we will check for the ASM data group. So DGM is disk group. Okay, DGM is disk group. So OCR vote. Okay, Oracle cluster and voting disk. Okay, so they are all both of them are lying on the same disk group. Okay, so likewise we can check the resources individually also. Okay, so for stopping the cluster aware we use CRSCTL stop CRS. Okay, we don't using -f for forcefully. Okay, we can also mention the -f. Okay, so one by one each and every resource is getting stopped. Okay, so you can see one by one it's proceeding, and on the node 2 also it is proceeding. Okay, so it will take some time, but it will stop each and every resource. Then after we can shut down the servers. Okay, so CRSCTL has performed its operation on node 2. Okay, so now we will check on the background if any process is running. So nothing is running, we are good to stop the server.